Okay, my friends, nuclear electronic flood theory. We know how bar magnets attach like that. Now, if they are in a reverse polarity, they push away from each other. Okay, so this won't attach. It's being pushed away. See it? If I turn it around, boom. Okay, so we all understand that. Now, my contention is that every single particle that exists, and we're going to call them electrons, consists of bar magnets just like this, but they're round. Okay, and so this right here, if you can see, you see the different white and black spots, and as I roll it, you see the white and black spot changing around. I hope you can see that. All right, you see that? That is one of these particles that is part of, this is an electron. That was an electron. It has a positive side and a negative side. And it's just like this right here. Okay. Now there's 1,836 of these electrons per proton. And at 1,836, they become stable. They want to stay together. But then you get 1837, 1838, 1839. Then you end up with isotopes. Now, each one of these little balls has a positive and a negative. We can see it, you see? Just like I showed you on this tape here. It shows that there's a negative and a positive to it. Now, when you get 1,836 of them together, you have a stable proton. Add extra stuff, you end up having isotopes. Now, here's the current model, hydrogen. This tiny, tiny, tiny electron, and then a gigantic proton, which is positive, that's negative. But they're both the same electron volts. That's a positive one, that's a negative one. It just doesn't work. It doesn't work for anything, nothing. There's isotopes, there's no possible way it could possibly work with that. Absolutely impossible. This is electron flood theory. They all attach together like this. That is a proton. Now here's hydrogen in my world. You have the proton plus a little extra, couple of extra electrons that create, instead of a neutral core, when there are 1836 particles, you have a bunch of little extra electrons that it really doesn't want them there. There's too many. They're not resident stable. So they are the weak force, and they can get thrown out easily. All right? Now, you have one additional particle being held away because there's more negatives in here now than it can handle. So this negative says, I want to get in. It says, no, 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 you're going to have to stay exactly that far away because that's what your magnetic value is. You're going to stay right there. You're half an inch away, case closed, and don't go any further, don't go any farther. You can stay there, and it will stay there. All right? Now, that, in my world, is a hydrogen, and it also is the basic proton at 1836. All right? Now, we're going to go a little deeper, but that is the basic structure of everything is composed of these. And the more of them you add together, the more of them they will turn into a molecule. And they will do exactly what they're supposed to do based on there's some kind of program running in there. Because every single one of these can be anything. It can be anything at all. These are inside of you, all over the place inside of you. And guess where else they've been? They've been inside of stomachs of every kind of animal, and the intestines of worms, and urine of people, and feces, and everywhere else. And they're all inside of you. Exactly same particle that was somewhere else before is going to be in you, and then it will take on a life process. And it will cooperate with its neighbors to do whatever was necessary to make your life function. Or any living thing. There's something in there that knows what's going on in my world. All right, I'm just going to basically read to you what the electron flood theory is. And this is version 2.0 because the version 1 had a positive and a negative particle. I don't think that's the case. I think they're all a single particle, and they are back to back. Before I get into this, and read it to you. I'm going to show you the light experiments, and then you'll see why I'm going to make the statements I make. Now, I make a lot of claims, and I'm not doing this to brag, but I did this for my whole life. And I worked in semiconductors, and I worked, you know, I was in the Army and nuclear missiles and all kind of stuff. So it's not something I'm unfamiliar with. I have some form of, you know, I mean, this goes way, that goes back when they were just starting to learn this stuff. Now, my contention is that this is what you're going to see in our light experiments. Alright, and I will explain this little Wile E. Coyote diagram here after you see the light experiments. But basically we're shooting a laser through 2 round drums. They're just, literally, these were nails. I don't know what size nails Rod used. Rodney Warren did the Venturi. Just by accident, he used nails instead of a slit, a flat plate slit, which they recommend to use. So this what caused this acceleration factor. That's what's called a Venturi. Just like airplane wings, it forced that to compress and accelerate. And then we could see plasma, bosons, Higgs, particles, the whole 9 yards, and that's what I will show you now. Okay, so once again, this was by Rodney Warren. He sent me all these pictures. I saw his work on the internet just by accident, and nobody was understanding it. He was just putting all these pictures up, and I saw it, and I said, whoa, I understood it. And he was using just a simple construction laser. This is a laser he was using, a GLM-15 Bosch. It creates a red pulse laser. And it comes back to this, and it reads how far away the thing was. So pop, these pulses are coming out. Now, what all of these little white dots you see around here are literally concussed electrons. They are free electrons that float everywhere in the atmosphere, and there is free electrons in every single thing, in every single matter. There's all kinds of free electrons. You know, I mean, there is some matter that will have all of its electrons locked up and be totally non-conductive, but that's the exception. Extreme insulators. Most things are semiconductors. All right, semi. They conduct, but not cascading conduction. You know, you got copper and gold and the platinum group metals. They cascade just. There's almost zero resistance in those. Everything else resists the flow of electricity. That means it is a semiconductor. Now, we're dealing with light here, and these are the same particles that are inside of semiconductor circuits that are moving through those circuits. Those little particles right there, exact same particles, identical same particles, but they're inside of circuitry, and they are pushed by magnets. A magnet will basically, electricity pushes things, pushes and pulls. That's what it is, magnetism, and that's how it's driven through the circuits. So that's light in its most basic form. And there's only one tiny dot in the center. That is what the light is. And it makes, just like a jet fighter going through a cloud, everything got to get away from it. And everything around it has to also get concussed. Because all this stuff is getting some form of concussion. That stuff is pushing everybody. You know, nobody can get away quick enough. So it all starts to glow a little bit. But the particle is only there. So let's see what that particle looks like. Alright, so don't forget, it's coming out of here so fast. This is where we're seeing it just doesn't do anything. It's too fast, and then it hits this, and these are all those little particles surrounded. Now, I was showing the central core of it, the dot that was spinning around a circle. All of these out here are not going to be glowing like that one was. That one is the glower. That's the one that excites these. And this row excites the next one, that row excites the next one, and so forth going out. And as they trail out further, they get less and less excited, and then you get to the edge where it's the end of the the field strength. That's the one that's spinning backwards. Now, I think I explained this before, but I just want to explain to you so you fully understand. When that light came through this Venturi towards us, it was all the same light. It was all red laser light. There was no difference. It was no difference. All those particles coming through, as you can see, are red laser light, except you'll see there's some different colors. And the reason for that is because they are extraordinarily, like this one is further out than all the rest, and it has really started to step down. This one is being crushed from both sides. See how it's flattened out? That gives us the purple strength, or that's more power. You see how small the rings are, but they're more powerful looking. These have a lot of rings, but they're not quite as, this one here is being crushed, let me put it that way. And that's why you see these different colors. But primarily it was all red laser coming out of here. This one here, however, my take, and this is just a guess, but I think it's a pretty good basis for this guess, is that that particle, instead of spinning to the right, it's spinning to the left. And it's like gathering its power into itself and turning, it's gathering its power instead of spitting it out to excite all these other ones. It's somehow restricting that power into itself. There's nothing being excited around it. You can see that. It's pulling whatever it has into itself. Now, whether it just owns its own self or it's pulling stuff out, back into itself, I don't know. These are spitting power out, and they will step down almost immediately, as this one is now, and it will end up going into just a very normal looking light. And I can show that. Well, let me show it to you. All right, this is a fabulous shot Rod got. That's a Venturi over here. The particles are coming out, spraying out. Now this is green, and you can see them there. Well, these are dipoles, back-to-back dipoles, and in my world, I'm going to call those electrons. All right. In other words, you got a positive and a negative, and a positive and a negative. One's this way, and the other one's upside down. They're glued together. All right, like two-bar magnets, exactly like this. Boom. Now, if they were upside down, they're going to push away from each other. You can't get them to go together. But when they go up like this, they're together. Now, when they come through and smash into something, I think they start to separate and go flying off and spinning like this. And that spinning creates those polar fields that we saw a minute ago. Now, there's spikes up the top and spikes at the bottom and the top. That is, wherever you see white and then you see black, that is absolutely magnetic. Yes and no. Okay, watch. I can show you right here. Very simple. You see that? These are those little ball magnets. You see the black and the white? You see the white all around the edges? So, when you have power and no power, that means something. That is the separation of charges. And I believe you can break this apart this way or break it apart that way. And you'll have one bar magnet and you'll have another bar magnet. And that's what light is. And when it crashes into something, they separate, creating these fields. And I'll show you light separating as it hits water. See, the beauty of having a school, the Mount Fossil University, have 70-something thousand people now, and they're all contributors. They're not just students, and I hand them a piece of paper, said, you said what I said, and now you're smart. No. They send me stuff, and they say, well, what about this? Well, this was my buddy Renz over in Polynesia. He sent me this. These are Higgs fields. That's what they are. They're Higgs fields. They're exactly identical to what we saw before. And why are they here in this air? Well, these new phones pick these things up. They are very, very sensitive in certain phones. Not every one of them does it. And Rod was a master at understanding this. And Renz, I got a bunch of people now to understand this. I don't understand as well as they do, to be perfectly honest with you. I like to see what they send me. But I can see exactly what it is. And those are Higgs fields. And those are because those light particles are concussing with water molecules that are in the air, which are the same molecules that I showed you before that created those glowing luminescent particles within, right in front of the lasers. No difference whatsoever. Now this is Renz again. This time he was in France, but I don't think there's any difference between the light there and Polynesia. Now he put his thumb, that's literally just his thumb like that, and then, well, what do you have? You have a tumbling Higgs. That is the tumbling white Higgs. That is the God particle that they always, oh, you're the Higgs. Well, it is. That now, in my world, is an electron feeding into this atmosphere, forcing things to get away from it as it spins. What happened on the other side of the Venturi is it created the leptons. And it separated out the frequencies of the light, which is this. All right, red is a very long frequency. Green is here, and blue is like this. Now, I don't know if they're the same diameter of the spin. I kind of tend to doubt it. I think that the blue is going to be a real tight spin, and that's going to be a green is going to be a more little longer, and the red is going to be that real long, and it splays right out. I mean, that's what leptons are: blue, green, red, and they're supposed to take on that. Blue is tight, green is a little looser, and red is your loosey-goosey. That's what I'm seeing. Accounts for everything that they ask for, and I will show you what they're asking for. It's exactly what they're asking for. Electron neutrinos. That's what I'm saying they are. They are electrons in a shower. And why do I say that? Because the accelerated high voltage electrons, higher than 1 electron volt, because they are accelerated, they smash into the 1 electron volt electrons, and they send them cascading away, exactly what they do in a semiconductor, except this just happens to be physically accelerated light instead of feeding it through junctions and that sort of stuff. Now, it's Cherenkov. This is Cherenkov radiation, the white glowy radiation. That's Cherenkov. And then you get this, multiple neutrino electron showers. Now, let's see what CERN has to say. And that's what CERN works with, these chunks. I think most people heard of CERN and how expensive their work is, and what they're trying to do is to find out what the smallest particles are, what makes up everything. And I can tell you what makes up everything is electrons. There's one small particle, and every other bit is made out of that one bit. And as I said, there's 1,836 bits in what we would call a proton, 1,837 what we call a neutron, and they are resonance stable at 1,836, less stable 837, and very unstable as you go on and on and on, which are the isotopes and nuclear radiation, because it's the nucleus where those resonance stable particles are supposed to be don't have the correct number, so they spit them out. Now, they are smashing them head on, their particles. Their particles are 8,000 times bigger than my particles. So what happens? They smash and they get a mess. Now then they go looking through the mess to see what broke. It's like throwing a vase on the ground and seeing what broke out of it. And they got 8,000 times. Now you see these little tiny bitty ones? Those are very similar to ones we have. But they all display the same field characteristics, these round field patterns. Even though this one here that's creating this pattern might have 100,000 particles in it, and I have one. You know what I'm saying? They're 8,000 times bigger than my particles. Let's put it that way. So these are a bunch of them, and every now and then they'll get a little one that's very similar to ours. So That's a Higgs field. That's what they were. They come head on. Now, what does that mean? They just go flying all over, and then they just got to dig through the debris. Ours, we're funneling them through a venturi, which is an orifice. When it comes out the other side, it's elegant. You can see exactly the patterns. You don't have to go digging through a bunch of debris. Now, let me show you something else about the spinning particle. Okay, this is the light spinning through, as I showed you. It's just like that, spinning, spin, 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 and it's spinning through the venturi, and I'm going to display this. I'll make a little Wile E. Coyote diagram for you in a second. But here it goes, zip, zip, zip. It's coming down, bang, it hits there. If it goes straight through the center, it goes this way. If it's coming up over this way, it comes up and around. If it's coming under, it comes up over this way. So some are going to hit way over here, over here, over here, over here. They're going to be coming all over the place here. So some of them are going to be way out, some are going to be less out. But you can see more dense inside, less dense outside, just due to the nature of where the particles are going to impact and their circular nature, which is quite obvious to see. Now, let me show you something else. I'm going to leave it at this. This, I don't know if I mentioned before, but this very, very seriously perplexed me, how that you could have black and white light and then all of a sudden it turns completely white. But then I noticed this here, this little black spots. You see that spot right there? And that spot right there, how they're just spots. Now, I think it's spinning through, and one way it's coming off to this side, and one way it's coming off to this side. And you're getting the black spots are starting to, in other words, they're all coming out in disarray, like these two bar magnets. Okay, so when they came into here, they were together. And they just crushed with everybody else, and they all went into this kind of activity, insanity. And they're all coming out of here in insanity. And at this point, some of them start to glob back together, and they do that, or they do that. And then they travel off to become red light again. That's all I can say. Now, Mud Fossil University, we're doing everything, and the reason we're getting somewhere in this is because there's 70,000 people that are contributors. They're not just repeaters of what I tell them. You know, I've learned a ton of stuff from them, trust me. There's a lot of stuff I had to change because of people tipping me off to things. So that's what we want to do, is examine what we have, not discount and say you have to say exactly what I say or you're not educated. No, that's not education. We're going to fix education.